Hello everyone, welcome back to Let's Crack J in English, the channel of Unacademy. And I'm Jeetendra Dixit. Just let me check my voice first. Yes, good. All right, so now we will continue. Here's my profile. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. Now, before we begin, let me tell you about the Unacademy subscription. So as we know, Unacademy is India's largest online learning platform. And if you are preparing for IIT-JEE or any other competitive exams, you can prepare with Unacademy. And for IIT-JEE, let me tell you that you can have two types of subscriptions on Unacademy. One is Plus subscription and other is Iconic subscription. What is Plus subscription? If you are preparing for IIT-JEE, then you can have this Plus subscription. One moment. So I was saying that if you are preparing for IIT-JEE, then you can have Plus subscription. In this, you get access to daily live classes of all the educators who are teaching for IIT-JEE. You can access their live session, and uh, and you can follow educator of your choice. Okay, so this is complete freedom you have, and all live tests and quizzes will also be accessible to you. And the live classes which I was talking about are very interactive. You can ask your doubts during the session. Also, you can chat with your educator. You can participate in polls. So it makes sessions very interactive. All the courses are well structured. Well structured means everything is pre-planned. You can see the schedule of all the upcoming lectures in well advance. So this is the unlimited access which you get by taking this subscription. You can subscribe for 1 month, 3 months, 6 months, 12 and 24 months. 12 and 24 months you can compare, have the very low per month average compared to any other package. And of course you'll get 10% discount also in all the subscriptions, which is given on the right hand side. After 10% discount, you can see the price list using a referral code. So you can use my referral code JEET1 to get instant 10% discount. And second is Iconic subscription. In Iconic subscription, you get access to daily live classes, all the benefits actually of Plus. And apart from that, you get a personal coach who will guide you throughout your preparation for IIT-JEE. Your test analysis will be done in a personalized manner. Your study planner will be customized. Bi-weekly reviews will be given highlighting your progress. All right. So this is about the Iconic subscription. You can buy Iconic subscription for 6 months, 12 months and 24 months. The 6 month subscription is 38,000, 12 month subscription is 65,000 and 24 month subscription is 1 lakh. Okay, this is the price, and you can use the same referral code to get instant 10% discount. All right, and after 10% discount, you will have to pay the final price list. So you can see that in any of the subscription you can apply this code to get 10% discount. All right. Now the next point which I was saying is this Unacademy's learning app, which you can download from Play Store, and after downloading it, you can start your attending free content on the platform. And to access that free content, now you'll have to use a code. So you can use the same code JEET1 to access that free content also. In that free content, let me specify the special classes which are taken by the educators of Unacademy. Every day a lot of special classes are going on, so you can attend unlimited special classes on the platform. All right, unlimited special classes on the platform without paying anything. Okay, and you can learn. So this was, and the last information about Unacademy's combat, which is on 28th of December, next combat, which is highly gamified uh, and highly competitive exam. So you can participate in that. You can enroll for that using the same code JEET1. You can enroll it. All right, so use that code for enrollment also. Also, you can win a lot of prizes and rewards in that exam. So just enroll for it. It is on 28th of December. Now let's begin the session. Before we begin, you know, so actually a small portion was remaining, that is called homogenization of a curve, and then after that pair of a straight line, and after that we can start circles. So are you there, Gia? Bhavesh, Gia, all right. Today's doubt session, yes, Bhavesh, today's doubt session, finally, huh? And I will take it, don't worry. For today's doubt session, I have taken proper rest. All right. Okay, so let's do homogenization first, and then we will begin circles. So we already know what is homogeneous curve. 2-degree homogeneous curve in x and y always represents two straight lines passing through origin. Now suppose there's a curve. Okay, S is a curve given by, say, S is a curve given by ax square plus 2hxy plus by square plus 2gx plus 2fy plus 1. Okay, so this is S is equal to 0. It might be parabola, it might be ellipse, it might be pair of straight lines, it might be circle, it might be hyperbola. All the curves are represented by same 2-degree equation. Is that okay? All the curves are represented by same 2-degree equations with different conditions on A, H, B, G, F. Okay, in different conditions के साथ you can change the curve. So S is equal to 0 is one of the curve, and a line L is a line whose equation is Lx plus My. I'm writing is equal to N. All right, and this line is intersecting the curve at 2 points. Okay, intersecting, these two are intersecting curves. So L intersect, any line will intersect 2-degree curves at maximum 2 points. All right, these are the scenarios. Like this is the curve, so it can be like this, it can be a tangent, and it can cut the curves at 2 points, but not more than it, but at most 2 points. Okay, at most 2 points. So either 2 points will be distinct or 2 points will be repeated if line is tangent, or no point common. So I am saying that L intersects S, L is equal to 0, line intersects S is equal to 0 at 2 points, 2 distinct points, A and B. Okay, A and B. Now if they ask a question, then what is the angle subtended by AB at origin? Okay, something like this. Any question in which origin is associated with A and B, that means he is using these 3 points, origin and A and B. Okay, so then whenever he asks about the angle, this angle AOB, so AB is called intercepted portion of line between the curve. AB, what is called AB? AB is called intercepted portion of line L between or cut off by S is equal to 0. All right, oh, okay, let's write it C. By mistake I've written 1, although it doesn't matter, so you can take any value, but let's write C, generalized constant, arbitrary constant C. by mistake I wrote that one. All right, Jia. So whenever, first of all, what is homogenization and what does this represent? Okay, then we'll talk about this intercepted portion. Okay, so I want to make this curve s is equal to 0, which is not a homogeneous curve because it has 2-degree terms, it has 1-degree terms, and it also has a constant term. All right. So if I want to homogenize this curve. Homogenize means I want to make all the terms of this curve as 2-degree, same degree basically, you know. So same degree you can do either by reducing the degree of 2-degree terms or increasing the degree of constant and make it 1 degree. All the terms you can make 1 degree, or you can make all the terms 2 degree. So it's easy to make all the terms 2-degree terms using the equation of line. Okay, using the equation of line. First of all, let me tell you this thing, that whenever you have a 1-degree homogeneous equation like ax plus by and you multiply it with another 1-degree linear equation lx plus my. Okay, this is 1-degree homogeneous, this is also 1-degree homogeneous. When you multiply them, you get 2-degree homogeneous curve. 2-degree homogeneous means you'll get a term. If you expand it, you'll get term of x square, you'll get term of y square, you'll also get term of xy. Are you understanding this thing? Right? Whenever you multiply 1 degree. So basically 2-degree homogeneous is product of two 1-degree homogeneous. 3-degree homogeneous you can say is product of 1-degree homogeneous into 1-degree homogeneous into 1-degree homogeneous. Okay. But even as you multiply homogeneous into non-homogeneous, that means if you multiply ax plus by to ax plus by plus c, then all terms will not be of 2-degree. You'll get 1-degree terms also. Right. Okay. So to meet this 2-degree curve, homogeneous curve, we are not going to change these three terms. We'll keep these three terms as it is. Okay. Which three terms? Ax square plus 2hxy plus by square. We are going to increase the degree of these two 1-degree terms, the term of x and term of y. You can see these two terms are 1-degree terms. So if I multiply these two terms with another 1-degree homogeneous expression, all right, or another 1-degree homogeneous term, then they will become of 2-degree. All right. And this is a constant term which can be multiplied by a 2-degree term to make it 2-degree. I hope you're getting it. So this is what we are going to do. So to make s, a 2-degree homogeneous expression, we are going to use L. Okay, line L. Okay, using this line. How to use this line? You can see this L can be written as Lx. This line, equation of line can be written in this form: Lx Lx plus my divided by n. This expression is equal to 1, right? This can be written as 1. Okay. So I'm writing Lx plus my upon n, and there's a reason to write in this particular form. I'll tell you later. Okay, so I think this is clear. Lx plus my upon n can be written as 1, and of course if you put any point of the line in this expression Lx plus my upon n, it will satisfy the line. That means it will become 1, right? But only the points of line. If you put this point in this equation, you will get 1 is equal to 1. But if you put this point in this equation, equation number 1, okay, equation number 1, you won't get left hand side 1 because this is not on the line, right? So it won't satisfy the equation. So left hand side expression will not be 1. So left hand side expression will be 1 for which values of which for points which are lying on the line. Okay, I hope it is clear. Huh? So we are going to use this. You can see this is 1-degree homogeneous expression. Now this expression ax square plus 2hxy plus by square. See, this is 2 degree, already 2 degree, plus 2gx plus 2fy. Okay, this I am going to multiply it by 1. Okay, I'm multiplying it I'm multiplying this by 1. Okay, and c I'm going to multiply by 1 square. So it is actually same. Now in place of 1 I'm going to write ax square plus 2hxy plus by square plus this 2gx plus 2fy multiplied to, I have now put the value of 1. This is lx plus my upon n. Okay, this is equal to 0. And plus c times of lx plus my upon n the whole square is equal to 0. So can you see this? Now this equation is of type ax square. It will have only 3 types of terms: x square, xy and y square. So I'm writing ax square plus 2hxy plus by square. Okay, it will become like this. So using that line, you have made that 2 degree equation 2 degree homogeneous, 2 degree general equation as 2 degree homogeneous equation. Now have you got it? Have you understood this process of making the making this general equation as 2 degree homogeneous equation? This process. Have you understood the process? Okay. Now see, the biggest point is, what does this represent? What does this new equation represents? Okay. Can you Gia, can you guess this, which point will satisfy this equation? This equation number 2. In this plane, you can see this diagram. See this diagram, okay? And let me know that 3 types of points are there. Okay, 3 or 4. I'm writing the points. Point number 1. This is point number 1, which is on the line. This is point number 2, which is point number 2. This is point number 3, which is not on the line, neither on the line nor on the curve. This is point number 4, which is common point. Okay, A and B, 2 points are common basically. You know? This is 4th type of point. All right, and this is okay, 4 type of points. That's it. First of all, let me make it clear. First of all, we know that this 2 degree new equation, this third equation represents a pair of lines passing through origin. This is what we already know. Okay, I don't know which 2 lines, but this equation will represent 2 lines passing through origin, right? We know that. This is for sure. No matter which point will satisfy, but this equation will represent 2 straight lines passing through origin. So I don't know what we have made, but whatever we have made will represent 2 straight lines passing through origin. All right, is that okay? This represent 2 lines passing through origin. Is that okay? This is we know, and we want to know more about these 2 lines. Okay, before knowing, I have asked you one question that I mentioned 4 points in the plane: 1, 2, 3 and 4. You tell me which point out of which point or points out of these 4 will satisfy equation number 3. Tell me that. Very nice, very nice. Fourth will satisfy. Why? Because for point number 4, which is lying on the line, this part lx plus my upon n will become 1. This will become 1. So you can see this part is going to be 1. This part here, this part is going to be 1 for point number 4. This point is going to be 1 for point number 4. So if you put point number 4 in this equation number 2, then these 2 green I have circled 2 expressions, lx plus my upon n, they will become 1, and the remaining expression is basically the equation of the curve. And if you put 4th point in that curve, and it will become 0, because that 4th point lies on the curve also. So that means 4th point will satisfy. What about point number 1? For point number 1, Yes, those circles will become 1 because point number 1 does not lie on the curve. So that expression, remaining expression, which is equation of curve, will not be 0. And similarly for point number 3, by the way, that will not be s. Okay, lx plus my upon n will not be 1. So it will be something different curve. So we don't know anything about 3. It might be 0, it might not be 0. For point number two, again, it will not be 0 certainly. Why? Because lx plus my upon n is not 0 and point lies on the curve. So you're putting the point number 2 in the equation of the curve, but now it is a different equation. It is not the same equation because you have changed the coefficients of x and y as well as the constant. So I think this explanation is understandable for you. Like you already got the point, but I was explaining it. Okay, so that means now we know one more point, that these lines which we have formed, actually the 2-degree homogeneous curve which we have made using s is equal to 0 and l is equal to 0 is actually representing two lines passing through origin, of course, and also passing through the points of intersection of s is equal to 0 and l is equal to 0, and passing through origin and points of intersection of L is equal to 0 and S is equal to 0. Is that okay? So these are basically lines. These lines, this homogeneous curve is representing these two lines, which are lines which we have formed, lines which are joining the points of intersection to origin, points of intersection of S and L to origin. Okay, so as soon as we homogenize this curve S is equal to 0 with L is equal to 0, we get the combined equation of these two lines. If he is asking for this angle, suppose he is asking what is the angle subtended by the intercepted portion of line by S is equal to 0 at origin. That means he is asking for this angle AOB. Now we know the formula. We won't solve these two curves S is equal to 0 and L is equal to 0. We will homogenize this curve and we'll get the pair of straight lines, and after getting it, we can write the formula of angle between A or B, 2 under root of h square minus AB upon A plus B, tan inverse of that. I'll get the formula. So in most of the cases, they ask this angle. What is the angle? So this is the main question. What is the angle subtended by the intercepted portion at origin? Make sure at origin, not at any other point. At origin. Whenever you see, because see, this is a concept which we learn here, and sometimes we use one or two questions will get in circles also, one or two questions will get in parabola also, similarly one or two questions will get ellipse also, right? Suddenly when question based on this comes, because S can be any curve, so this question you'll obviously will form in circles also, you'll get this question in ellipse also. Now, there will be a line which will cut ellipse at 2 points, and then it'll ask what is the angle subtended by this segment, intercepted segment at origin. Origin might be center x for some curve, vertex for some curve. So he will not directly say origin. He will say what is the angle subtended by the segment at the vertex, and you know vertex is origin. So ultimately you need to do homogenization, because solving line with curve is slightly lengthier sometimes if numerical values are not given. So we are not going to solve them to find A and B, and then we'll find the slopes, and then we'll find the angle. All right, so I have told you what kind of questions we uh, expect in this. Is that okay? Now let's do the problems, okay? Now let's do the problem. Let's homogenize the curves and we'll see what kind of, just a moment. So wait a minute. Okay, I'll give you one question in between. If line passing through a comma 0 intersects y square is equal to 4ax, a variable line, okay, intersects y square is equal to 4ax at 2 points a and b, and angle subtended by AB at the origin is 90 degree, then find slope of the line. I'm removing this variable line, it will be a fixed line. We need to find the slope of that line. Try this one. Are you getting any answers? So I'll write the equation y minus 0 is equal to m times of x minus a. You can write like this. and then always write this line as y minus mx is equal to minus am. Divide by this constant, you can write mx minus y divided by am is equal to 1. Okay, always make 1 by dividing by this constant. This is the line, and the curve is given, which is very simple. Only two terms are there. Y square is there minus 4ax. So let's homogenize this curve. This is a parabola, by the way, and this line is intersecting. It's a variable line. I don't know which line is this, and this is subtending right angle at the vertex. What origin is basically vertex of this parabola. So at this point, anyways, even if you don't know the diagram of this parabola, then also it works, no problem. You can take origin somewhere else. The meaning we know, the meaning of question we know. So we need to homogenize this. Homogenize second curve using 1. Homogenize second using 1. And that what will happen if you homogenize? You'll get this. You'll get these two lines. Combined equation of these two lines, right? You'll get combined equations of these two lines. This is AO and BO. All right. So, and then we can use that because this angle is given 90 degree. This is given actually, right? This is given 90 degree. So let's homogenize first of all. So it is y square minus 4ax multiplied by mx minus y divided by m. Is that okay? Am is equal to 0. Is this all right here? Now you expand it. So it is am into y square minus a by the way, a you can cancel. So it is my square minus 4m x square, right? Yeah. Something is wrong, I think. What is wrong? A comma line was passing through a comma 0, so I have written the equation of line y minus 0 is equal to m times of x minus a. Then it was mx minus y is equal to am, so I have divided by this. So mx minus y divided by am is equal to 1. Then I have multiplied it to 2 degree term, so 4ax, so 4ax into mx minus y divided by am, and a got cancelled actually. Okay, so a got cancelled. Oh, okay. So basically in this case it is not possible. That's why we are not getting the value of him. So this is plus this is plus 4xy is equal to 0. By the way, to make now this is, we have got the equation of combined equation of OA and OB, and because this angle is 90 degrees, so coefficient of x square plus coefficient of y square should be 0. I actually randomly formed this question, so now I'm getting this m minus 4m should be 0. That means m is equal to 0. M is equal to 0 means it should be a horizontal line. So if you put m is equal to 0, so actually it is going to be x-axis only, but x-axis is not going to cut this curve at 2 points. The diagram is going to be like this. And actually what happens, the line which passes through a comma 0 is the focus of this parabola, that always subtend angle more than 90 degree. This angle is always more than 90 degree, no matter which chord you take, focal chord. So that is what is happening actually here. So no angle is 90 degree. That's why answer is coming out to be 0. So that's why it is, I mean, we are not, this is not a proper question. I'll give you the second one, another one. What we were going to do, that coefficient of x square plus coefficient of y square is equal to 0 because angle between the lines is 90 degree. All right. Have you understood the problem in this question here? I'll give you the another one. Okay, now solve this one. Uh, if the straight line joining the origin, if the straight line joining the origin to the points of intersection of the straight line kx plus hy is equal to 2hk with the curve x minus h the whole square plus y minus k the whole square is equal to c square are at right angles then h square plus k square is equal to, you have the options 1, option B is c, option D is c square, or c, sorry, option C is c square and option D is 2c square. All right, so you need to choose one of the option. Now do it. This is a proper question. The straight line joining the origin to the points of intersection of the straight lines, this straight line given a straight line and the given curve are at right angles, then we need to find the value of h square plus k square. First, you need to expand that 2 degree curve. Then you can see 2 degree terms and 1 degree terms and constant term. Then you will multiply it by the expression, 1 degree expression, which you'll get from the line. All right, I'll tell you. Are you not able to make it? I mean, are you not able to homogenize this one? Is that so? Okay, let's homogenize. Have you understood the problem, the meaning of problem? I mean, this is a circle, by the way, but it's okay if you don't know circle. Just make a curve, 2-degree curve, and a line is cutting this curve at 2 points. This is the line. This is the curve. Okay, and he is saying that angle subtended by these two, the points of intersection A and B. Again, whatever point you take, A and B. These 2 points are subtending right angle at origin, right? This is what he is saying. This angle is 90 degree if you take this point as origin. Okay. So what we are going to do, we are going to find the equation of combined equation of OA and OB by homogenizing this curve S by the line. So line we are going to write kx plus hy divided by this hx is equal to 1. Is this point okay? I have written the line in this form. Now you can see this is 1 degree term, this is 1 degree term. Okay. Okay. Now the curve is S expanded. So this is x square plus y square. These are only 2 degree terms. Keep them aside, and the rest remaining 2 terms are 2hx plus 2ky. Write these 2 terms in brackets. Minus I have taken common, and minus actually plus h square plus k square minus c square. These are constants, so this whole thing is a constant. All right, this is 0 degree term. Yeah, 2hk. All right, 2hk. Okay, so now we are going to increase the degree of this term by multiplying it by the linear 1 degree expression which we have written in equation 1, and we'll multiply it by 1 square. So now homogenizing 1, homogenizing S with L. Okay, so that is x square plus y square as it is, no change. Then 2hx plus 2ky is multiplied by kx plus hy divided by 2hk plus this whole thing h square plus k square minus c square will be multiplied with kx plus hy divided by 2hk the whole square is equal to 0. Now this is the equation which has only 3 types of terms. Terms of x square, term of y square, and term of xy. So when you club these terms, you'll get equation like this: ax square plus 2hxy plus by square is equal to 0. Okay, this equation is going to be in this form. And because it represents OA and OB, and we know that it is given that angle between OA and OB is 90 degrees. So we know that A plus B must be 0. Is that okay? Are you understanding this point, Gia? If you are understanding this point, then we are very close to the answer. Let me know. Yes, okay. So see, to find coefficient of x square and coefficient of we know that we need to put coefficient of x square plus coefficient of y square is equal to 0. and rest we are not concerned about. Okay, rest of the terms of this equation. So just focus on coefficient of x square first. Let's write the coefficient of x square, you know. So the coefficient of x square, see, there will be 2 or 3 terms of x square in this equation. So one term is this. I'm just underlining the coefficient terms of x square. Then you'll get this term as x square, and from here also you'll get perfect square, x square of, right? So I'm writing the coefficient. Coefficient will be 1 here. Coefficient will be minus 2h into k divided by this 2hk. So it is actually -1. Okay, plus I'll get the coefficient of x square from here also. This is going to be this into, this is k square upon 2hk. So I'll get this h square plus k square minus c square multiplied with k square upon 2hk whole square. Can you see the coefficient of x square? Have I written it correctly? You understood? Hello, Bhavesh. Are you understanding the calculation? Yeah. This whole thing is coefficient of x square. Okay. Now I'm writing coefficient of y square. Coefficient of y square is 1. Similarly, this is y square term, and you'll get y square from here also, which is actually again minus 2hk upon 2hk, and one term from here, this into square of this. So h square, this is h square plus k square minus c square multiplied to h square upon 2hk the whole square. All right, is equal to 0. Got it? Why are we putting this coefficient of x square plus coefficient of y square 0? Because we know that 2-degree homogeneous equation represents 2 straight lines, and if they are perpendicular, then coefficient of x square plus coefficient of y square is 0, right? Now we have got the answer. This and this will get cancelled, this and this will get cancelled, and in these two terms you can take this h square plus k square minus c square common. So if you take h square plus k square minus c square common, the rest of the terms are basically k square plus h square divided by 2hk the whole square is equal to 0. And of course this is a positive term, this is not 0. So this to be 0, h must be 0 and k must be 0, so line will vanish actually. So this is non-zero, this is not 0. So of course h square plus k square minus c square must be 0. So h square plus k square minus c square must be 0. And from this we'll get h square plus k square is equal to c square. Okay. So the answer is this. H square plus k square is equal to c square. Now you got it? Again? All right. Okay. I'll give you one more version, okay? Then we will finish it. Okay, try this one. If the line x upon a plus y upon b is equal to 1, cuts 5 times of x square plus y square uh, plus bx plus ay is equal to 9ab at 2 points, A and B, such that angle AOB is given 90 degree. In most of the cases, it is given 90 degree because you will make a homogeneous 2-degree homogeneous equation and then put the x square coefficient of x square plus coefficient of y square is equal to 0. If it is 60 degree, then you'll have to write all three terms and you'll have to apply tan 60 is equal to 2 under root of h square minus ab upon a plus b, and that will make question lengthier if numerical values are not given. But if numerical values are given, then you can ask angle also. It can be any angle, all right? But mostly it is 90 degree because to make the calculation easy in such questions. 90 degree, then find the condition. Find the condition on A and B. Of course, A and B, because you can see only two variables in this, two parameters. Find the relation between A and B, okay? Find the relation between A and B. Solve it. This Bhavesh was saying okay in between. I don't know for what. Was he trying to understand this problem? He's also funny. Keeps asking for doubts. Are you taking doubt class? Are you taking doubt class? And he will come up with that two linear equations of x and y as how to find the point of intersection. You are getting 2a square plus 2b square is equal to 5. That means you can factorize it. Can you find a upon b? Because in this question they can ask a upon b. I think you can find it. A upon b. Tell me a upon b. Yeah. Seems correct. Yes. बोर्ड्स की टेंशन आ रही है. Uh, yes, your answer is correct, but also find a upon b. Meanwhile, I'm solving it. So it is bx plus ay. Okay, line is already written in this form. Bx plus ay upon ab. All right, is equal to 1. So no need to change. Then just to make it homogeneous, 5 times of x square plus y square plus 5 times of bx plus ay multiplied to bx plus ay divided by this is ab and minus 9ab bx plus ay divided by ab, the whole square is equal to 1, is equal to 0. Now you just write the coefficient of x square plus coefficient of, so coefficient of x square plus coefficient of y square is equal to 0, and we will put that. So coefficient of x square is 5 plus, from this coefficient of x square is going to be 5b into b, yeah, so b into b upon ab. Yes, 2 and 1 by 2. So right. This and plus coefficient of y square from this is going to be minus 9ab. So it is minus 9ab into b square upon a square b square, ab whole square, right? Similarly, write the coefficient of y square also, that is 5 plus this is 5 times of, this is a into a, yeah, so a square, so 5 times of a square upon ab, and minus, in this you are going to get what, minus 9ab into a square upon ab the whole square is equal to 0. Are you getting all, are you also getting the same? So now b and b will get cancelled. Why am I getting b upon a? Was it written correctly? Bx plus ay, bx plus ay, yes, it was written correctly. Okay, anyways, let's simplify it. So it is 5 times of b upon, okay, let's multiply, first simplify it. So it is 5 times of, I'll write it here only, 5 plus 5 times of b upon a minus, this is, if we cancel b ab, then it is actually 9 times of what, 9 times of b square upon what, b square upon a square, yeah, b square upon b square upon no, b square upon ab, b square upon, yeah, b square upon ab, so that is b upon a, 9 times of b upon a plus 5 plus 5 times of a upon b, okay, 5 times of a upon b minus 9 times of this is last में a upon b, 9 times of a upon b. All right, okay, so just multiply it by ab and finally we are going to get 5ab. You can club these two terms, so it is minus 4 b upon a, minus 4 b upon a, and if you multiply it by ab, it is going to be minus 4a square, so minus 4a square, and then again you'll get 5ab, so it is 5ab again, and this term is going to be, this is 9 minus 4 upon a, 4 minus 4a upon b, so if you multiply it by ab, so this is also minus 4b square, right? Wait a minute, the first one was b square and the last one is a square, although answer is going to be same, but let me write it in order. This is, when you multiply it by b ab, it is going to be 4 b square, and this is going to be 4a square. All right, so you'll get this 2a square plus 2b square is equal to 5ab, and that is the relation, and even you can factorize it by making a quadratic in a upon b. So you'll get a is equal to 2b or b is equal to 2a. These are the two relations, and you can find a upon b also if they are asking for. All right, so we are done with homogenization. We'll keep doing questions on that. I'll bring some questions in practice session tomorrow. Tomorrow is the practice session, okay? So we'll discuss some questions based on now. Now we are done with all the concepts of straight lines. We'll have one or two practice sessions. Tomorrow is one. Apart from that, from next session, I'm going to start circles. Okay. Sufyan, what replied? Have you asked anything? I haven't got your message. Yeah, Sufyan, tell me. What do you want to know? Sufyan, you are the one who shared your what? Oh, you are the one who got my this WhatsApp number and this, what is that called? Telegram link. Huh? You shared your Telegram link. What do you want to know? I can't see your message. All right. Anyways, I'm finishing this session. We'll continue tomorrow 3 p.m. Okay, 3 p.m. is the time. Oh, I missed to message Raghav. He is asking for to no coordinate class today, sir. He wanted to do this topic. Oh, all right, Zia. Thank you. Take care. All right, Sofian. Bye bye. Take care.